I believe the last time we had notes in this class, we were talking about hair in the hair growth cycle. That is where we're going to pick up. We're going to pick up right where we left off, which was right here. So we have these little, let me actually go back. Attached to every hair follicle, we have these little muscles. This is a muscle. It's just really small. It's a really tiny muscle. Here's the muscle. Attached to every follicle, at the bottom, there's a muscle. And it attaches up towards the epidermis. So you can imagine that muscle contracting. If that muscle was to contract, it first would pull on this, and it would pull on this. If that was to contract, look what would happen. Stop. There we go. We would have goosebumps. Now I know all of you have had goosebumps at some point in your life. And in fact, if I'm scaring you right now, you're probably getting goosebumps. Why do you think we have this function inside of our skin? Well, what's the evolutionary advantage to having these little muscles pulling on our hair follicles, causing these bumps on the surface of our skin? Good thinking, Kim. She's asking, we know when we're cold. It definitely has something to do with when we're cold. I mean, personally, I know when I'm cold. It's kind of uncomfortable if it's really cold, right? You sense it. So I don't know if that's the advantage to this. There's probably something a little bit more survival related. Jocelyn says it alerts you. So possibly, what about that muscle contracting, pulling your hairs up straighter, and also creating these bumps in your skin? What advantage, direct advantage, would it give to you? Ooh, I think you're onto something, Tanya. To like feel if anything's on you. Okay, I didn't think about that. Well, it makes it look intimidating. Ah, okay, so that I would definitely agree with as a very important advantage. Think about what both Tanya and Will brought up. Makes us look more intimidating. Or think about how rattlesnakes alert their presence to something that's getting in their face. What do? Rattlesnakes make a noise, right? They shake their rattle. You ever seen somebody get into a fight before? What do? If you've ever seen somebody get into a fight, what's something that people naturally do? I'm saying unconsciously, but yes, they probably should tie their hair back. That's important, Kim. Oh, no mistakes. Well, think about, when we're talking about these evolutionary advantages, think about someone in the wild, okay? They're not going to have clothes on. What's one way to look more intimidating? So they flex, right? Good. Good, Jocelyn. Good, Kim. Why do you think they're doing that? To seem intimidating, right, Jocelyn? Yeah. To look stronger, to look bigger, right? To catch attention, to hopefully scare their opponent off so that they don't have to expend any energy in that fight. Well, imagine our bodies covered in hair. right? Because our ancestors were covered in hair. We've lost some of the instructions, so we don't make as much hair. Some of us make more hair than others. But even those of you out there that don't have that much hair on your arms and legs and body, it's because of certain little changes in our DNA. We've shut off some of the hair making. But think about if we were covered in hair. Think about a cat. What does a cat do when it gets scared or it's about to get into a fight? What does it do with its hair? Well, the tail goes up, right? It's going to make the cat look a little bit bigger. You ever seen a scared cat before? It does a curve thing, right? It's starting to arch its back a little bit. You ever seen the hair kind of puff up a little bit? So now we're starting to see one of the advantages to having these little muscles attached to our follicles. If we can cause ourselves to look bigger, like a cat is trying to do, primates, apes do this, gorillas do this, and we do share a lot of DNA. Chimpanzees do this. They make their hair puff out in order to look bigger. Same thing people do when they're going to get into a fight. They flex, they puff themselves up a little bit, maybe hold their breath a little bit to look bigger, maybe change their body shape. These are all programmed into our brain, deep, deep, deep down in our brain, to make us look more intimidating, to make us try to scare off the opponent. Not yet. Well, except for this last part down here. We didn't put this in here last time. So these little erector pili muscles, they have the ability not only to create goosebumps, but also to puff hair up. And now, we don't maybe even notice this is happening when we're scared, but sometimes we do. It also happens when we're cold. Why do you think we would have another advantage when we're cold to have this function under our or in our skin? Why would this help us when we're cold? Or how would it help us when we're cold? Tanya's asking, let her body know to control the temp. It's part of the way the body controls the temp. Kimberly's asking to keep us warm. If you've ever been cold before, what do people tell you to do when you're like outside and you're cold? What do people tell you to warm up? Well, layer up. Let's say you can't get any more layers. Those of you that have ever been cold before in a colder climate, you rub your hands. Okay, so we create some friction to create some heat. You blow on them, get some heat from inside of our core. What else do we do? That's, yeah, creating more friction, rubbing the arms. Anybody ever told you to like run in place if you're cold, or do some jumping jacks if you're cold? I grew up in a colder climate, so this is something that we'd have to deal with every day in the winter during PE or playing in a sport. It would always be cold, and the coaches would say, do jumping jacks to warm up. And when I was little, I didn't really know why I was doing jumping jacks. Thanks, Veronica. But what I found out is that by moving our body, by causing muscles to contract, I'm creating heat inside of my body. So any type of movement creates heat. Any type of muscle contraction creates heat. Wouldn't it be amazing if our skin contained lots of little muscles that on command would start to contract? It would be amazing, and that's exactly why we have those little erector pili muscles. So that when we're cold, our brain can send a signal to our skin to start generating heat. And it generates the heat by contracting all of these muscles, these erector pili muscles. Let me see what my next slide is. Not that one. So all these little muscles start to contract, they pull, and then they pull the hair up so that the hair stands on end. Not only is it a similar response to when we're frightened, but when we're cold, these muscles are our heat source in our skin. And so they're these little heat generators that we can use on command. Those evolutionary changes, Kim, happen usually randomly. The DNA inside of our cells, every time it's copied, it can create mistakes. And some of those mistakes, they happen to go by uncorrected. And those mistakes can create differences inside of our body. And sometimes those mistakes can lead to cancer. That's why we'll never really get rid of cancer, because cancer is just a natural part of us evolving. But sometimes those mistakes, those errors, can build an entire new structure in your body. We're talking about over generations. So it's not going to happen in your body. You're not going to evolve. But your children may be a little bit different than you are, and the children's children may be a little bit different than you are. And then, 10 or 20 generations from you, those little errors that have accumulated over hundreds of years can create a slight difference. And over thousands of years, we can see little changes in organisms. Unfortunately, I know some biology teachers don't really teach evolution that well, and that may be why this is kind of a hard concept to understand. But exactly, so evolution is fueled by cell mutation, correct? This is one of the reasons why we're probably going to be stuck with cancer until we find a way to literally just stay on top of everyone's bodies. Because sometimes those mutations can lead to cancer, sometimes they can lead to advantages. All right, so that's the erector pili muscles. I always like to talk about that because we have a quick little discussion on the advantage of things in our body. The next thing we're going to talk about is another structure, which we call an accessory structure in our skin, which is pointed at right here. So here's the hair follicle. Here's a hair shaft. This is a really thin slice of skin. This is human skin. And you can see the hair shaft coming out. Down here would be the hair root. Here's the follicle. The follicle is kind of broken open here. Whatever sliced it open also tore the follicle open. So it looks like it's kind of opened up bigger than it should be. But what we're looking at is this structure right here. This is a really important gland. We call it a sebaceous gland. So you can see it much better in this image where the hair is actually missing from the follicle. It's been torn out. And you see this duct, this opening that leads to the hair follicle. But over here, there's 3 glands. And these glands produce oil, or sebum, we call it. And that sebum has a really important function for that follicle and for the skin itself. So let's talk about the sebaceous glands. And I don't know why all of these came up all at once, but let me talk you through them as you guys write down the notes. I think I screwed up on the animation. So the sebaceous glands are our oil-producing glands in our skin. And inside those little sacs, so there's a little sac here, there's a sac here. You can see it better not sliced in half here. This is the entire sac, And they're always attached to hair follicles. And they provide really important lubrication for the hair. Imagine this protein-rich, dead structure coming out of our skin. It's constantly growing, constantly moving if it's in a growth cycle. If there was no lubrication, the hair would tear all of your epidermal cells anywhere near where that hair is coming out. And this can actually happen to people who have really, really dry skin. When their hair comes out, it can create problems that tear some of the outer layers of the skin when it comes out. And it can be a little bit, annoying. The oil not only lubricates the hair traveling out of the skin, it also creates a nice lubrication for the skin, because as the oil comes out, it seeps all over the outer layer of the skin. And as it seeps all over this outer layer of our skin, it creates a smoother, healthier skin on the outer layer of the epidermis. Keeps that outer layer of epidermis hydrated so it doesn't dry out as easily. And it also creates another layer of waterproofing on our skin. Now, there are certain parts of our bodies that produce more oil, more sebum than others. Top of our heads can produce oil, sometimes much more so during puberty. Our faces can produce more oil, sometimes a lot more during puberty. We'll talk about acne probably next week or the week after next. But the oil is really most important for allowing the hair to grow safely out of the skin. Without it, we would have tears all over the place. It would be really bad. And so up until now, we've talked about the hair follicle. We've talked about the sebaceous glands, which you also see here and here. There's lots of other accessory structures in the skin too, like these things, like these things, like these things. And so we need to talk about each of them because they're all really important to our skin. So the next thing we're going to talk about, the next thing we're going to cover are our sweat glands. Don't write anything yet. Just look at where the pointer is. We have two different types of sweat glands in our skin. We have one type of sweat gland that has a duct, a tube, that leads right to the surface. We have another type of sweat gland that has a duct that doesn't go right to the surface. It actually connects with the hair follicle again. And now, depending on whether the duct goes right to the skin, or to the hair follicle, determines what type of liquid that gets sweated out. And there's two different types of sweat that we can release. We have a clear, liquidy sweat, has a little bit of waste product in it. And that sweat usually is the clear sweat, that when your body gets overly hot, overheated, it cools itself down by releasing a liquid that then has to dry off. It's the drying of that liquid that cools our body down. There's another place that has a different type of sweat. Think of your underarms and think of your groin. That sweat happens to be a little bit different than the sweat that's released from the rest of our body. It contains a lot more waste product. It has a little bit more of a milky appearance to it, and it has a strong odor. And that strong odor, if we didn't cover it up with deodorant and shower daily or every other day, would be really strong. And if you think about, well, why do we have an odor? There's an advantage to being separate from someone else. And our ancestors would use that odor much more than we use the odor now. And in fact, we don't like smelling other people's body odor. So we tend to cover it up. We put deodorant and antiperspirant under our arms to not only cover up the odor, but to also block these sweat glands from secreting their odorous material. And then also in mating, different odors, different people would be a way that our ancestors would be able to differentiate one person from the other, especially if you lived in real tight compartments. So let's talk about the sweat glands. Here's a sebaceous gland. Here's the sweat gland down here that has a tube that basically shares with the sebaceous gland to the hair follicle. Please write sweat glands and underline it. I told you there's two different types. There's these sweat glands here. And then there's these sweat glands here. That's a horrible circle. This type of sweat gland, the one that secretes the clear sweat, and we find these sweat glands pretty much everywhere on the body, is known as a merocrine sweat gland. Sometimes we call it eccrine, but I'm just going to cross this out and say merocrine. That didn't work. This is a watery sweat that our body releases. It's about less than 1% sodium chloride, about 1% salt. And this is primarily sweat that's used for heat loss. When our body gets hot, our body knows that we can release liquid sweat from our merocrine sweat glands. Let me see if I can move this. Nope. And that liquid will eventually dry. And when the liquid dries, it pulls off a little bit of heat into the atmosphere around us. And so in order for sweat to truly cool us, you have to let it dry. We're not cooling down when we're sweating. We're cooling down when the sweat dries off. And if you don't believe me, take some nail polish remover, rub it on your finger, and let it dry. See what happens to your finger. Or if you don't have any nail polish remover, take a little bit of rubbing alcohol or a little sanitizer wipe. Rub it on your finger and let it dry. You'll see exactly how this process works. It works much faster with alcohols and acetones. These sweat glands are widely present in skin. Now there's another type of sweat gland called the apocrine sweat glands. This type of sweat is for body odor. And I have a hard time thinking about body odor because we don't really like body odor in our society. We don't really pay attention to it. In fact, we like to cover it up. But if you think about civilizations that don't do that, if you've ever been to France before, they don't like using deodorant and antiperspirant. So you get a nice little whiff when you go there of everybody's body odor. You know, ancient humans did not have ways of covering up their body odor. They actually used it to tell each other apart. And when I say ancient humans, I'm not just talking about the hairless versions like us. The category humans includes lots of different ancestor versions of us too, probably covered in hair. All right, so we need for this is the apocrine sweat glands. Ah, shoot. These glands start producing sweat at puberty. Some point in the beginning of puberty, you probably started to notice, or somebody started to tell you that you had a smell to you. And you were probably told, hey, you probably should start wearing deodorant. You're going to want to make sure you bathe and shower regularly because people don't like that smell. And it only really happens during puberty that these sweat glands, these apocrine sweat glands, get turned on. And they're attached to hair follicles. And we only find them in the armpit and genital area. That's it. We don't have any body odor producing sweat glands anywhere else. Just our armpits and then our groin area. Now we use deodorant, like I said, to cover up the odor, and then antiperspirant to stop these sweat glands from producing. You're basically plugging up the sweat glands so that the sweat doesn't come out. And you need to, apply it every day because that's why it's chalky. You need to apply it every day so that the plugs, you can keep plugging up those apocrine sweat glands. And it doesn't cause any problems to us physically to do that. It's just a way to eliminate some of that body odor producing sweat that comes out. What do we got next? And because we, don't have as much time as we would if we were in class, there's a couple things that we're not going to go into deep dive into like we've been doing with some of these other structures. And so we're not going to learn about every single one of these accessory structures, but I am going to talk a little bit about each one. And in fact, I want you to think of a certain space about 1 inch by 1 inch. So I drew it out on a piece of paper here. That's 1 inch by 1 inch. If you compare it to my finger, it's about from the tip of my finger to my first knuckle here. And then if you were to square that, and then you were to take a area of skin 1 inch squared out of somebody's body, then we could actually count the amount of structures inside that skin. I'll get to that in a second. Let me clear these. And so what I'd like you to do is just write down some of this information regarding how much stuff is in a square inch of skin. So in 1 square inch of skin, it contains, so please write that down, 20 blood vessels. And Kim's asking if body odor is natural or is it bad? Bad and good depends on who's looking at it, who's deciding, right? It's a very subjective. Good and bad is very subjective to the person who's describing it. If you were talking to ancient humans, body odors probably be very good, right? It's a way to tell people apart. It's a way to determine whether that person is your mate or not. You have to remember, when we're covered in hair, it may be a little bit harder. Body odor now may not be as good to us. It doesn't give us many advantages, and in fact, we try to cover it up. I don't know if I would say it's necessarily bad, though. Either way, it's natural. Nothing is wrong with the body when it's producing odor. Click on the whiteboard, Tanya. You're welcome. So in 1 square inch of skin, you have 20 blood vessels. You also find about 65 hairs and erector pili muscles attached to those hairs. Hair follicles, but just, you get the idea. There's also 75 nerve fibers running through a square inch of skin. And those nerve fibers connect to the erector pili muscles to get them to contract. They connect to blood vessels to get the blood vessels to change shape. They also connect to our sensors for heat in the skin, which we have about 78 of those. These nerves also connect to the sensors for cold. We have about 13 of those. Much less than ones for heat. So things that are hot, we're going to feel quicker than things that are cold because we have more of those sensors on our skin. And in fact, heat can do much more damage quicker than cold can. But then there's a lot of sensors for pressure. But 160 to 165 sensors for pressure, for touch. And now that varies depending on where on our skin we're looking. Skin on the palm of your hand is going to have more pressure receptors than skin on the top of your hand. And you can tell that the palm of your hand is much more sensitive than the back of your hand. We also have about 100 sebaceous glands in a square inch of skin. And so every hair follicle either has one or more sebaceous glands attached to it. Lots of sweat glands, though. Our skin has the ability to produce a lot of sweat. For 1 square inch of skin, about 650 sweat glands. About 1,300 nerve endings. Any nerve can have lots of endings coming off of that one cell. And that attaches to all these different sensors, to the muscles, to the blood vessels, to the sebaceous glands, to the sweat glands. Because remember, things have to tell those items what to do. And that leads us to the last item that I want you to be aware of, that there's about 19.5 million cells in a square inch of skin. So think about how small a cell is. It kind of gives you a little perspective. I hate how that thing pops up. Gives you a little perspective as to the scale that we're talking about. Remember, all of these accessories are found in the dermis of our skin, or at least they originate in the dermis of our skin. But on top, that epidermis, there's about 19.5 million cells. So there's a lot of stuff in a square inch of skin, a lot. We're almost done, guys. We're just going to talk about nails, and then you guys get to rest. Jason, there's those helicopters fly all the time. It's annoying. All right, so if you missed all that stuff, you can go back and get it on the whiteboard. I want to keep moving because I don't want to take the whole period for notes. Just leave some space if you missed any of those. And the last thing we're going to talk about today are these things that are growing out of control on this lady's hands. What the heck are those? And did you guys know that they could grow that long? Yeah, I know. They look like claws, right? So your nails can grow pretty much as long as you let them grow. And the length that you grow them determines on how much care you want to give them. Your nails will keep growing and keep growing and keep growing and keep growing until they break off. Now, normally we cut them before they even get anywhere near that size. But this lady, she won a world record for having her nails grow out that much. There's some other people who have done that too, but I think at the time of this picture, she had the world record. I personally don't know how you can do anything with nails like that. Honestly, it seems like it would just be really annoying to have these really long nails, but yeah, the long nail goddess, I think you're right. I think that's what she calls herself. So anyway, what the heck are these things and where do they grow from? Well, the nail grows from the tip of our finger. Now, why do you think we have nails? Like, what would be an advantage to our fingers to have these hard structures on the tip? So Kim's asking to protect the tip of her fingers. It's a good question. What are some other thoughts? What else, guys? I know you can do better than not putting something up there. Think about your nails. What kind of advantage does it give to the finger? So maybe to scratch gives us a little bit of a weapon, right? Something to help grip stuff better. Good thinking, Will. I also agree with Kim that it does protect the tip of your finger, right? Look at the bone of your finger here. We have a lot of tissue that kind of rounds the finger here, but having a hard structure on the top can help that all this tissue hold its shape much better. And it can also help us grab things a little bit better. Having those nails gives you ability to kind of grab onto things better than you would if you just had smooth tips to your fingers, right? And I'm sure, yeah, there's some kind of an advantage to being able to scratch with them too. So we have these cells that grow from the tip of our fingers, and there's a few different structures to the nail itself. So let's talk about them. The part that you see is known as the nail body. So this is the part that, if you were getting your fingernails done, you would have those painted. That's the nail body. And the nail body can actually grow really long, like we just saw with this lady's fingernails here. But it's not growing here. It's actually growing all the way down here. We call this the nail root. Just like the hair root, the very tip bottom of the hair root is where the hair grows. This nail grows right here at the nail root. And then it grows in this direction, in this direction, in this direction, in this direction. And it just keeps pushing the older dead cells out. And you get your nails. Right where it attaches to the tissue above is known as the cuticle. And then that little white structure underneath we call the lanula. So this little structure here is in the lanula. It's just an area where the epidermis is basically holding on nice and tight to that nail body up top. So let's take some notes. Nails. This is our last slide of the day. So the nails consist of the nail body. The nail body is this large portion of the nail. The part that grows over and out of the fingertip is known as the free edge. The nail body is basically the visible part of the nail. And it's made of the same cells as the outer layer of our epidermis is made of, the stratum corneum cells. It's just a lot denser. So you can almost think of your nails as an extension of your stratum corneum, but much, much densely packed. And it just so happens the denser packed cells create this structure that adds some strength and rigidity to the tip of our finger. It also probably can be used for scratching, grabbing, whatever else. Now, underneath the nail is the nail bed, and it sits kind of loosely attached to the nail bed. It's attached here, but it can be pulled off. And in fact, if you've ever lost a fingernail or a toenail before, you will know that these nails can sometimes pop off. They can sometimes come off. Now, if the nail comes off, usually if there's nothing damaged back here at the nail root, it will grow back. If something hits your finger or toe really hard and it damages this area, then it's not going to grow back. You will have no more nail growing out of there. I had a ingrown toenail once, and I didn't go to the doctor for a while. Never had one before. The side of my toenail was the toenail itself was growing into the side of the toe there, and it would bleed and it was uncomfortable, and I thought it would kind of clear up on its own. Never assume that. If you have something that hurts, if you have something that isn't getting better, you need to go to the doctor. And I waited too long. I was busy. I think it was the year I was student teaching, so years ago, and I was really busy. Well, finally, I couldn't walk anymore. It got so painful. Yes, if you've had them before, well, you know, they hurt. And then it started to get infected, so I knew I had to go to the doctor at that point. And the doctor basically looked at me and said, you waited too long to come in here. I'll give you some antibiotics, but I got to take the toenail off because otherwise it's not going to heal. So luckily they didn't just go and pull it off, because that would have hurt, because it is kind of being held on loosely here, and then it would be really painful here to pull it out. But they numb the toe. The most painful thing of the whole procedure was just getting my toe numb. The needles going into the toe because they got to go deep. Once it's numb, then it's totally fine. They just pull it off. And then the worst part after that is once you regain feeling, then it's got to heal. And it took a while before that nail bed healed and it didn't hurt. You know, taking a shower was particularly painful. But then after, like, I think it took me about 9 months to a year to grow the toenail back. Toes heal much slower than hands because there's less blood flow moving back and forth. Oh, yeah, I've done that before. I did that with my thumb right there. I got a piece of metal underneath it. It lifted up the fingernail. It's fixing itself. It's growing back, but it can be painful, huh? And sometimes when it gets lifted, the only way for your body to heal it is to completely lose the nail and then just grow another one back. Sometimes that'll happen. So the nail bed itself is made of epidermis, and it's the epidermal tissue underneath the nail body. So we're talking about that stuff right there. And those cells hold loosely onto the growing nail as it's coming out. Oh gosh, Kim, that's horrible. I don't know how that's funny. Ugh. Ugh. I'm sorry. Now, the site of nail growth is the nail root. And this is the part of your nail growing system that you don't want to damage. Because once the nail root gets damaged too much, you may not get a new nail growing back. And it's not the end of the world not to have a nail. It actually, some people that have had their toenails or fingernails taken off, they even still paint them. And it doesn't look that much different. Now, the little area of stratum corneum that basically lies right on top of the nail body, creating a nice seal between these more vulnerable cells underneath in the outside world is known as the cuticle. And you can actually, if you look at your fingernail, that little layer right there is known as the cuticle, right between the nail body and the skin on the top of your finger. And if you've ever had your nails done before, they sometimes scrape that cuticle back a little bit because it can look kind of gnarly, especially if you get your nails painted. And it doesn't hurt all that much because it's all stratum corneum. It's dead tissue anyway. Then the last thing to be aware of is just that the lanula is the whiter part of the nail. It's just basically a part of the epidermis that's pressing against the nail bed above it a little bit harder so it appears white. You guys have the day off tomorrow. Lucky you. Yeah, it's a duty day for us teachers, so I'll be working. You can always email me if you guys have questions, but you do have the day off tomorrow. I'm glad you asked that, Amelia. I would recommend getting yourself caught up on Canvas if you have nothing else to do. That would be a really good idea. No, the free edge, actually my fingernails need to be cut. The free edge is the part like right there that's you usually cut when it's growing. The lanula is the white part. So this is the free edge here, and then the lanula is back here. I think whoever is working from the classroom, they may be, but you guys won't be able to go to the classrooms. No, most of us are not going. I'm not going to the classrooms. I'll just be working here. All right, guys, you took a lot of notes today. Well done. We're going to stop right there after the word nail on that last line, lanula.